Hello viewers, welcome back to my channel. This is Ranjiraj and you're streaming on the Study Beast. So in my previous video I discussed regarding the perceptrons, that is the single layer perceptron. So after the completion of the video I told you that in my next video I'll be discussing regarding the problem or example based on the single layer perceptron. So I thought that you need to understand certain concepts, certain algorithms, certain formulas in order to get into that actual problem and how to solve those step by step. So I have made a video, and this video is based on an algorithm called as the Perceptron Convergence algorithm. So you need to understand this first. It's a very simple algorithm, just mathematics is there, simple calculations, multiplication and addition is there. So let's get started. So ready? So first of all, this Perceptron Convergence algorithm has 5 basic steps to solve it. So the step 1 goes like this. First you have to initialize. What to initialize? You have to initialize all the weight vectors to 0 and then perform the following computations for time step n is equal to 1, 2, 3 and so on. When it is going, you have to execute till what is your n is actually desired to. And next, when you do the initialization, you need to have the activation. You have to activate those weight functions, or from the synaptics you have to activate those. So at time step n, activate the perceptron. So when you reach that particular threshold, or when you reach, if n is kept as 20, so when you reach at step 20, then activate this perceptron by moving on to step 2 and by applying this input vector, that is xn, and desired response dn. So in that video I've discussed that simple model of the perceptron by combining the bias. So in that there were many fields like xn, dn, bk function and yn function. So I've listed out these functions here. So xn basically is like a column vector which consists of m plus 1, that is m inputs are there multiplied by 1, and like it goes on in a sequence. And this so is a column vector, so we need to convert it into, like for addition we need to convert it into a row vector. So for row vector we are doing the transpose of this column vector, and when you take the transpose you get in this manner, that is plus 1 xn, x1n, x2n up till xm and so on. And then we have the wn, that is the weight vector. So weight vector is also the similar manner like the input vector, but it has got some bias function. Why? Because in the summing junction we had the bk, that is the bias function, that is the bn bias. So for that we need to include this, and the rest goes like this. And dn, this you can see is the actual desired response which we want, and yn is the actual response what we get after all the iterations and the processing. And finally there is one parameter called as the eta, and it is a learning rate parameter, and it is at positive constant less than unity. So it's simple. So it will be like a learning rate parameter, like it will be 1 or some other value for that. So let us see the steps for solving this. And after you complete step 2, let's move on to the computation of the actual response. Now first we have done the initialization by initializing all the input vectors or the weights to 0. Then at step n we did the activation, right? So after the activation, now we do the computation of the desired actual response. So the actual response is done with the help of this formula, that is yn is equal to, so yn is your actual response, is equal to sgn. Sgn, I will say what is it, and sgn function takes wt, that is the transpose of this one, and multiplied by the inputs multiplied by this xn, that is the input vector multiplied by the weight vector. And this sgn is called as the signum function. So in that I have discussed there are 3 main functions called as the activation function, which were Heaviside function, piecewise linear function and sigmoid function. So that was just for small computations. So for larger computations and for complicated problems we use the signum function. So signum function takes the range, like it is for positive 1 when x is greater than or equal to 0, or if it is minus 1 when x is less than 0. So this is more similar to your, what you can say, the Heaviside function. So Heaviside function has +1 and it has 0 for x it is greater than 0 and x it is less than 0. So these are the two things which differentiates between the Heaviside function and the Signum function. And next, moving on to step 4, we have the adaptation of the weight vector. So after you compute this, why you need an adaptation? Adaptation is required in order to retrain, or if we find that the desired or the actual response is not the one which we desired, then we have to retrain those set of data. So for updating the weight vector of the perceptron, so we don't update any input vector, we update the weight vector. So the weights are increased or decreased. So those weight vector is increased by wn plus 1 just by incrementing 1. We updated wn, the earlier weight vector which we had from this, plus this eta, that is the learning rate parameter, and this eta takes a function that is the difference of the desired response from the actual response multiplied by this input vector, and this desired response is +1 if xn belongs to c1, that is c1 here from the program perspective it is class 1, and -1 if xn belongs to c2. And next, the final step is the continuation. Like if you got this, then you need to continue further. So increment time step n from step 2 by one and go back to step 2 and do all the process right from activation till continuation. So it's just simple. First you have to do initialization, then you have to do the activation, then you have to do the computation, then you have to do the adaptation, and finally the continuation. So this is all about the Perceptron Convergence algorithm. So hope you found this video helpful. If you found this video helpful, please hit the like button, and if you haven't subscribed to my channel, please subscribe. Thanks for watching this video. If you have any comments or queries related to this algorithm or any other concept, please put it in the comment box below. Thank you.